So now we're going to do an independent samples t-test where we compare two independent samples. Here's my example. A statistics teacher wants to compare his two classes to see if they performed any differently on the tests he gave that semester. Class A had 25 students with an average score of 70, standard deviation 15. Class B had 20 students with an average score of 74, standard deviation 25. Using alpha level of 0.05, did these two classes perform any differently on the tests? So, we have 7 steps in an independent samples t-test. First we will state the hypotheses, then we'll state the alpha. We're going to calculate the degrees of freedom, state the decision rule, calculate the test statistic, state the results, and then state the conclusion. And step 1 is to define the null and alternative hypotheses. In this case, we're going to start off with the assumption that the means of Class A and Class B are equal. That's the null hypothesis. In the alternative hypothesis, what we're testing is we're testing to see if the means of Class A and Class B are any different. We're trying to see if they had different test scores throughout the semester. Now the alpha level is just 0.05 because I said use 0.05. That's usually what it's going to be. It might be 0.01 or something like that, but usually it's going to be 0.05. Now we have to calculate the degrees of freedom. And this is how you calculate the degrees of freedom when you're doing an independent samples t-test. Degrees of freedom are equal to n1 minus 1 plus n2 minus 1. Basically it's each sample size minus 1 and then you add them together. So I do 25 minus 1 plus 20 minus 1 and I get a degrees of freedom for this test of 43. We're going to use that when we find the critical value a little bit later. So now we're going to state the decision rule. Now I said to use an alpha level of 0.05, so we're basically looking for the 5% of the least likely events. We expect that 95% of the time the mean will fall within 2 points, and outside of that those would be rare events. So if we got a rare event like that, we could reject the null hypothesis because it's very different from what we expected to find. So here is our t-table. Remember that we are doing a two-tailed test with alpha 0.05 that has 43 degrees of freedom. So I have those two areas marked in red. And when I draw the arrows over there, that's how I find out that our critical value is 2.0167. So basically we expect our t to be between negative 2.0167 and positive 2.0167. If it's outside of that, we will reject the null hypothesis because that is a strange or unlikely event. And that's where the decision rule comes from. So if t is less than negative 2.0167 or greater than 2.0167, we will reject the null hypothesis. That is our decision rule. So now we actually have to calculate the test statistic. We have to calculate the t. Now there's going to be a lot of numbers coming up, so remember that at any time you can pause the video if you want to write something down, because I might have to go through some of it kind of quickly. So this is the t equation, and on top you can see that I have on the right mu1 minus mu2. Now that's expected to be 0, so we can just get rid of that and just have that in the t equation. I just wanted to include that because that is the full actual equation, but I wouldn't worry about that too much. This is the t equation we're going to work with. It has sample mean 1 and sample mean 2, which we already know. It has n1 and n2, which we already know. And then it has sp squared, which is actually the pooled variance. And we're going to need to calculate that before we put it in the equation. Using this equation right here, the pooled variance is equal to sum of squares 1, which is ss1 plus ss2, divided by df1 plus df2. So we need the sum of squares for each of the samples and the degrees of freedom for each of the samples. So now I'll show you how to find those 4 things. Degrees of freedom for each sample is easy. It's just the sample size minus 1. So like sample size for N1 for Class A is just 25 minus 1 or 24. And the sample size for Class B is just 20 minus 1 or 19. That's easy. Now the sum of squares is the variance of each times their respective degrees of freedom. Now remember, variance is just standard deviation squared. So like for SS1, we know that the standard deviation of Class A is 15. So if I square that, I'd have the variance. And when I multiply the variance by the degrees of freedom for that, I get a sum of squares of 5,400. And the same thing for the second one. For sum of squares 2, I find a sum of squares of 11,875. So now that we have those 4 numbers, I can just plug them in right there and find out what the pooled variance is. The pooled variance in this case is 401.74. Now your equation might be a little bit different and you might not have this pooled variance part. The reason I'm showing you this extra step is because this will always work regardless of what your sample size is. Sometimes if you use different equations you have to mix it up a little bit depending on if your sample sizes are equal or if they're different in this case, like we have a sample of 20 and a sample of 25. The equations I'm using will always work when you're comparing two samples in an independent samples t-test. So now that we have this pooled variance, I'm just going to delete that stuff and move it up there so I have some space. And now we have all the stuff and we can just plug it into our t equation right here. So I put in the two sample means of 70 and 74. I put in the pooled variance, which is 401.74, and I put in the two sample sizes, which is 25 and 20. And after going through that whole process and solving for all of that, I find out that our t is negative 0.67. So now we will state our results. Remember that our decision rule was that if t was less than negative 2.01 or greater than 2.01, we were going to reject the null hypothesis. In this case, our t was negative 0.67. Now that's in between those two numbers, so we're not going to reject the null hypothesis. We're actually going to, well, we're going to do not reject the null hypothesis. So we're still going to start off with the assumption that the classes have equal means on this test, or on the test given throughout the semester. And that's what our conclusion would be. There was no significant difference between the test performances of Class A and Class B. T equals negative 0.67 with a probability greater than 0.05. We can conclude that there is no difference between Class A and Class B. And that is an independent samples t-test.